A photon has momentum of magnitude 8.24 exponent -28 kilogram meter per second. Determine the wavelength and energy of this photon. Okay, so what is a photon? Photon is a particle of light, yeah, a light particle. So you see, light we normally regard as a wave. Okay, here it regard the light as a particle because it has momentum. So a light also has a momentum. Okay, momentum. A photon has a momentum. Momentum means this is the P. Yeah, P. So the question asks us to find the wavelength and energy of the photon. So wavelength is lambda, energy is E. Okay, so how to find the wavelength for the photon? Okay, photon, a light particle. We use the de Broglie wavelength formula. De Broglie wavelength formula is lambda equal to h over momentum. H over momentum. Yeah, photon has a momentum. So just substitute and see what's the answer. Okay, h is the Planck constant, 6.63 exponent -34. Okay, divided by the momentum, 8.24 exponent -28. Okay, let's calculate. Okay, so the answer is 8.046 exponent -7 meter. Is it correct? 8.04 nanometer. Yeah, so it is near to it. 8.046. No. We can make it exponent. Just make it exponent -9. If exponent -9, this one multiply 100. That means 804.6 exponent -9 meter. Okay. Multiply 100. This one become divide 100. So you get -9. So the -9 become the nanometer. Yeah. This -9 exponent -9 become nanometer. So the front is 804.6. And this thing become the nanometer. Anyway, it is just optional. Yeah? Optional to change to nanometer. It's not compulsory. You can just leave the answer in SI unit. Normally we just leave at SI unit meter. Okay, if SI unit meter, this is the answer. If in nanometer, that's the answer lah. Okay, so and then want to find the energy of the photon. Energy of the photon, we can energy of photon is HF because it has a quantum. The quanta is a quantum of the quantum of energy. A quantum of energy is HF. Quantum of energy is HF. But since we already got the lambda, so we use Hc over lambda instead of HF because we don't have the frequency. So we use lambda because we already got the de Broglie wavelength. So just use the wavelength. So we use E equal to Hc over lambda. That's the energy of one photon. Okay, so let's calculate and see. So H is again 6.63 exponent -34 and multiply by the speed of light 3 exponent 8, and then lambda is 8.046 exponent -7 meter. Okay, so what's the answer? Okay, what's the answer? 6.63 exponent -34 times 3 exponent 8 divided by 8.046 exponent -7. Okay, so the answer is 2.47 exponent -19 joule. That's the answer. Okay, is it correct? Yeah, 2.47 exponent -19 joule. That's correct. Okay, so another way to get this is to get the energy is use the formula E equal to mc square. Okay, E equal to mc square because actually this formula lambda equal to HO momentum, actually it derived from this formula E equal to mc square together with E equal to HF, E equal to mc square and E equal to HF combined, we get this de Broglie formula lambda equal to HO momentum. So we also can use this one. How to use this one? Because it gives us the momentum P, isn't it? Momentum P. So from here, we can see momentum is actually mass time velocity. The velocity for light is the speed of light, C. Okay, speed of light, C. So here we can make it, that means mc times C, isn't it? Because C square. So this mc become the P. So energy of the photon is actually the momentum of the photon multiply the speed of light. Let's try and calculate and see, do we get the same answer? Okay, so the momentum given is 8.24. Okay, 8.24 exponent negative 28, and the speed of light is 3 exponent 8. Okay, 3 exponent 8. So let's calculate. Yeah, the answer is 2.47 exponent negative 19. Is it the same? Is it the same as below? Yes, exactly the same. So what I can say is this formula lambda equal to HO momentum actually derived from the Einstein theory of relativity, E equal to mc square, and also the Planck's formula, E equal to HF. These two formula combined, we get this formula actually, yeah, for derivation. Okay, so that's why this one energy, you get the same answer. You just use the energy equal to momentum times speed of light. The momentum given P multiplied by the speed of light, you still get the same energy of photon. Okay, so these two answer is correct. Let's move on to the next questions.